So in this video for Module 0.2, we'll work out some examples on factoring. As before, I will mostly just show you, here's the procedure, here's how you do it. I may at times talk about concepts a little bit as well. So the first one, we're going to factor, and the way that this one factors, there is a method that many books will show that I don't think is very useful. I will go ahead and talk about it a little bit, but I don't find it to be useful. So one thing I notice is that this number is even. That's a little bit of a clue. And if I'm lucky, and the numbers aren't too large, I will recognize that 144 is the square of something. So I notice that, hey, this 24, this is 2 times 12. Well, negative 2 times 12, right? And this 144, hey, this is 12 squared. So this number 12 is special. This is going to help me do the factorization. Okay. So basically, once I recognize that number 12 is common, I can just say, well, this is x minus 12 squared. And that's it. I'm done. That's the factorization. If I want to rewrite this as x minus 12 times x minus 12, say I'm not totally sure, and I want to FOIL it out, right? And I want to make sure that this works, well, then I can do that, of course. I can check that I'm doing this correctly. I got the right answer. So if I do that, so first, so x times x squared, outer, so negative 12x, and then inner, negative 12x, and then last, negative 12 times negative 12 is plus 144. And when I combine like terms, of course I get x. And in fact, I'm going to run out of room, so I'll do it up here. X squared minus 24x plus 144, which is what I started with. So that worked. I don't really like this approach of looking for the 2% of the time that this is going to happen, where what you're trying to factor is already a square, like the two factors are the same, right? Like this. That's super rare. So I don't find it that almost every algebra book will tell you to do this. It's one of the steps. It's like step 3 or whatever. But to me, it just doesn't make a lot of sense. So I would prefer just to use the AC method. So I'm going to do that over here, which is the more generalized way of doing it. So if I have something like x squared minus 24x plus 144, the AC method means the coefficient here in front of the x squared is a 1. There's an implied 1 when there's nothing written. There's a 1. 1 times x squared, right? So the AC method is called that because the standard... Sorry, struggling with the interface here. The standard format for a quadratic expression is ax squared plus bx plus c. Plus bx, sorry, plus. So the AC method means you take the first coefficient and the last coefficient and you multiply them together. So in this case, 1 times 144, which would be 144. Relatively simple. 1 times something is just that number. So then I'm going to look at all the different ways of factoring this. And then there's going to be a lot of numbers. It is not so simple. And in fact, let's do this. Once I get started, I like to, if I'm starting to get a little bit ahead of myself, if this is even, I like to cut it in half and double that one, and that gets me another factorization. So half of 72 is 36. If I double 2, I get 4. Half of 36 is 18. Double that, I get 8. Half of that is 9. Double that, it's 16. So I get a bunch of different factorizations that way. Just by cut that in half, double that, and go down row by row by row. Now what I'm going to do is I'm going to divide this by 3 and multiply that by 3. I can borrow a factor. We talked about factoring in the last video. So 3 and 48. And now that this is the big one, I'll cut that one in half and double that one. So 24, 6, 12, 12. And that might be all of them. And what I notice is that 12 plus 12 is 24. Okay. What I'm looking for is, since this is positive, right? Then the numbers in pairs are either both positive or both negative. And since this is negative, I know that I want my two numbers to be negative. So really, what I ought to have negatives for all of these. I don't have to worry about the minus sign until later. I don't have to write it if I want to leave it off. It's not necessary to write it this way, but oops, might as well. So negative 12 and negative 12. That means that negative 12 plus negative 12, or if I want negative 12 minus negative 12, negative 12 minus 12 rather. This is negative 24. That's going to tell me how to rewrite this negative 24. So this is x squared minus 12x minus 12x plus 144. And you might be thinking already, wait a minute, that was way less writing. We're already doing more work. Well, this was quick because I recognized this immediately. I was able to do all the arithmetic mentally. I recognized it immediately. And this will happen 2% of the time that it works out like this. It factors in this way. This method always works. If factorization is even possible, then this will work every time. So although it is quite a bit of writing, and it's inefficient in this case, what's a good? I'm trying to think of a good analogy, but basically the method that has the broadest use and is most efficient most of the time is the one you probably should be using. When there are special cases where you can save yourself half the effort 2% of the time, well, maybe that's useful, maybe it isn't. I think in this case it's not that useful. Okay, so let's go back over here. What I'm going to do next is called factoring by grouping. I'm going to look at these two terms and factor out the common factor, in this case x. So x times x minus 12. And then here, the common factor is 12. But if I just factor out 12, I'm going to run into a problem. Let's go ahead and write that and see what happens. If I factor out 12, notice that there's no minus here and there's a minus here. There is a minus here and there's no minus here. This plus minus is not the same pattern as this one. And think of this as being like plus x. You don't normally write it, but it's not minus, it's the opposite plus. So what I really want is I don't want that. I want to factor out a minus, so this will be plus, but I'm sorry, I was circling a blank spot, which looks like a 0. Plus, but I'm not going to write it. I'm just going to, because it's odd to write plus x. You don't need to write anything there. I want to factor out the minus here so that this guy and this guy are identical. Okay, I want the two parentheticals to be the same. The reason for that is, now that these are the same, if I think about the concept of a common factor, now x minus 12 is the common factor between this term and this term. Okay, so just like here, I factor out an x. Both terms have an x, I factor it out. Here, both terms have an x minus 12, I factor it out. So what I'm going to do is this. I'm going to take this guy and just put it here, and this guy and put it next to that one. Okay, those two guys go together, kind of like this x, the one copy, and the 12 go together here. Okay, after I factored out that x in that step, right? And then this I just tack on there, and there's two of them, sure, but I'm factoring, so two copies get represented by 1. And I factored that. And of course, excuse me, of course, these are the same results. And the one on the right is more writing. It's a more generalized approach. This is called the AC method. Okay. And it will always work. If there are quadratics that don't factor in a nice way, but not like they'll need roots or imaginary numbers, some weird thing. If you're going to have factorization with nice clean numbers, then the AC method always works. This approach does work, and it will save you time when it works, but it only applies 2% of the time. So to me, it's not that useful. Anyway, moving along. So this one's going to be a lot easier in some ways because the numbers are so much smaller, but you have to remember that there's a 1 right here, is the coefficient there. So I've got, change colors here. I got a 1 here, and I got a 1 here, okay? Now, what I want is to use the AC method. Essentially, I'm going to take the number -6, and I'm going to factor it. Well, it could be 1 and 6 negative, or 1 and 6 negative, right? Or it could be 2 and 3 negative, or 2 and 3 negative. And I want to find the pair, the row that adds up to be +1, right? Well, hey, that's this one here, -2 and +3. So I'm going to rewrite this term by breaking it into two pieces. Instead of having 1x plus 1x, I'm going to have -2x plus 3x. So x squared minus 2x plus 3x minus 6. And if I had swapped the order here, like 3x minus 2x, that would have been fine. The order being different doesn't affect the result. Go ahead and do that. It's fine. Don't worry about the order that it's in. And my notice is there's a common factor here. And you should pause the video and think about it. What is the common factor? What do both terms have? And the answer is 3. Both terms have a 3. So, and then also here, what's the common factor? Right? What do both terms have? So pause the video, think about it. Both terms have an x, kind of like the previous one. Both terms here, both terms had an x, right? So erase that. So factor out the x that both terms have. X minus 2 is left over, plus 3 that they both have. X minus 2, and conveniently, we have x minus 2 twice, repeated. That's because these problems are made to work out relatively, I don't want to say easy, but nicely. You get a factorization. As long as you do this separation correctly, you get repeated factors. Not repeated factors, but a common factor. You get that to show up so that you can do the rest of the factorization. So now, take that x, take that 3, get the common factor that they both share, put that at the end. Okay, factored. And if you multiply this out, if you FOIL it, right, if you do first, it means those two guys, right? X times x, x squared. Outer, x times -2, so minus 2x. Inner, 3 times x. And last, 3 times -2, -6. You combine like terms, say equals. I'm going to have room here. And I get x squared plus x minus 6. Of course, I get the same thing. So you can always check your work when you're factoring. Just FOIL things out, see if you get the thing that you started with, and then you know that you did it right. There's actually another way to do this, but that comes later in the course. So there's a separate way to check for this, but we'll get to that later. Okay, so for this one, well, again, I'm going to use the AC method. There are other methods. There's something called sometimes called slide and divide, which if that's what you learned in high school, then that's probably fine. If you already know how to factor and you just have a different method, that's okay. My only problem with slide and divide is that the reason it works is actually very complicated, and I imagine you weren't shown why it works. You just shown, well, you do this, you get the right result. Why? Let's not worry about that. That's okay sometimes, but just take our word for it is probably not what you want to do when you are working on getting a degree in science, math, physics, chemistry, biology, so forth. Just take someone's word for it. Well, they said it's true, so it is. Why is it true? Well, don't worry about that. That's not really how science works, so it's maybe not the best attitude to have, at the college level. So, well, I got 1 in 30, right? Oh, and also, this is positive, meaning both the numbers in my list in each row should be both positive or both negative. But because I have a minus sign here, they're both negative, because this -11 has to come from negative values, right? So, potentially -1, -30. If I add those, I don't get -11. Okay, how about -2 and -15? That makes -17 when I add them, so no. Okay, how about -3 and -10? Well, that makes -13, which is not quite what I want, right? How about, let's see, what else is there? Oh, yeah. -5 and -6. You add those, you get -11. Okay, so x squared minus 5x minus 6x plus 30. I'm doing the AC method. So step one, identify the product of those two coefficients, 30 in this case. Step 2, make the list of factorizations of that number. Step 3, identify the pair that adds up to make that middle coefficient. Step 4, go ahead and rewrite your expression with that breaking apart the middle term. Then I can factor by grouping. What do these both have? Well, they both have an x. Factor these by grouping. What do they both have? They both have a 6. But as with the previous example, notice that there's a 1 there, right? I've got plus, minus, minus, plus. The pattern of the pluses and the minuses is different from here to here. They aren't both plus minus, and they aren't both minus plus. So I need to factor out a -6 from the second group. So I will have a x times x minus 5 minus 6 times x minus 5, of course. Now, I've got this repeated factor, right? So these guys go here, x minus 6, x minus 5, and I'm done. And again, if I want, I can multiply, I can FOIL this and check the right result. Okay. Next one. Now, this is where things get a little bit harder because we have a 3, not a 1. So the previous examples, there is something we could do that saves us a little bit of effort, but then it doesn't work here. So I was using the AC method the entire time because now we kind of need it. Things have gotten a little bit harder. So AC method, remember A is, A is the first coefficient, C is the last coefficient. When you have the quadratic in descending order, x squared, x, and then no x at all, right? So 3 times -8 is -24, okay? Since this is negative, since this is negative, my mistake, the two numbers in my factorization will have different signs. One's plus, one's minus, so that they multiply to make a negative. And, excuse me, since this is negative, this means the greater value should be the negative one, okay? So I could have 1 and -24. The greater value is negative. That does not add up to make -2. I could have 2 and -12. That does not add up to -2. Add up to make -2 either. And I just go from here. And I could go by guessing. I could, like I said, cut this in half, double this one. That's a technique that you can use. So I'll do that. So 4 and -6. And hey, what do you know? That adds up to make -2. So I haven't even listed all the combinations. There's other pairs that could work, but I don't need to bother because this is going to work. So 3x squared plus 4x minus 6x. And again, if I were to swap these two, that would be fine. The order does not matter. You'll get the right result regardless. Now, what I want you to notice at this point is we have, use the highlighter. We have plus, plus, minus, minus. The plus minus pattern is not the same. So in the second group, we have to factor out a negative value. So here, common factor is x. X equals 3x plus 4 minus common factor. So I already know it's going to be minus because I'm factoring a negative for reasons that I had said. So think about it. What am I going to factor out? What is the common factor? Pause the video if you need to. Think about it. So -2, those numbers are both even. And notice that again, in the parentheses, I have the same thing repeated, 3x plus 4. Okay. So now 3x plus 4 is a common factor. I'm going to take these two guys, put them together, and get my factorization. I'm done. That's it. Okay. Well, let's do another one. Do we have more after that? Yeah, 2 more. Okay. 3 more. Okay, same thing, just more of the same. So 8 times 3, AC method, 8 times 3 is 24. And I'm going to factor this, well, 1 and 24. Everything's positive, right? Positive, positive. So no negatives involved at all for this, for this example. 2 and 12, 4 and 6. Hey, there you go. Adds up to make 10. So 8x squared plus, you know what I'm going to do? I'm going to switch the order. Okay, I'm going to put the greater number first to show you that we still get a result. And in fact, maybe we should do it both ways to show that we get the same result. So what's the common factor here? Pause the video if you need to. Think about it. What's the common factor? Well, it's going to be 2x. And what's left over? Well, 4x plus 3. It's a little bit harder because we factored in a number and an x, right? Plus, well, there's no common factor here. 4x plus 3 already matches that. So I'm just going to factor out a 1, I guess. Just so I have something to write. I'm representing the factorization with something. So now that I have these two, highlighter, these two parentheticals match, now I can put the 2x and the 1 together. There we go. But you know what? I think what we'll do is I'll redo it in a different color, and I'll put these in the other order, and we'll see that we really do get the same thing. Okay, so I'm going to rewrite this with the two middle terms, the 6 and the 4, in a different order. So 8x squared plus 4x plus 6x plus 3. Okay. Right. 8x squared. Oh no, I did. I was gonna. Okay, I did. Okay, fine. I didn't realize I had put them in the other order. I thought I had to do it again. Okay, so common factor. Well, 4x now, right? 4 goes into 8, right? So 4x is the common factor. What's left over? 2x plus 1, right? It's a common factor here. Well, I guess that's 3. So 2x plus 1. And notice that these now match, right? So now I put the 4x and the 3 together. And there we go. We get the same factorization, but the difference is the order of the factors. When you switch the order of the terms, when you break apart the middle term, the choice of what order you write them in only affects the order of the factors at the end. And when you have two things that are multiplied, the order doesn't matter. So 2 times 3 and 3 times 2 are the same thing, right? 2 times 3 equals 3 times 2. Yeah, that's true, right? That's the commutative property of multiplication. So these are not meaningful differences. It's just, the order's different. Whatever. That doesn't matter. That doesn't affect the, how the, well, later on we'll call these functions and there'll be other stuff going on. So this is not a meaningful difference. It's a superficial difference. Okay, well, I guess we can go on to the next example then. So this one is a special kind. This is called a difference of squares, and there's a couple ways to deal with it. So let's do this. Let's rewrite this. We'll do this the long way, and then we'll do it the short way. I'm going to rewrite this as 4x squared plus 0x minus 1, because there's no term in the way it's written originally that has x that's not squared. In a quadratic expression, this term here is called the quadratic term. It's squared. This is called the linear term, and this is called the constant term. So quadratic expression has all three: quadratic, linear, constant. And if it's written in such a way that one is missing, you can force it to have that term, make it not missing exactly, by putting a 0 as the coefficient. 0 times x is just 0. So if I wanted, this could just go away. And this is the same thing, 4x squared minus 1. Okay. So now I'm just going to apply the method, AC method. What's A? 4. What's C? -1. So I'm going to have -4, and I'm going to look at how does that factor? Well, because, oh, wrong tool there, because this is negative, one of the numbers in my factorization is positive, one is negative. Their signs are different. Because this is 0, they need to add up to make 0, okay? So, 1 and -4, well, no, that's not going to work. Oops. -1 and 4, no, that does not have to make 0. 2 and -2, yeah, that adds up to make 0. Awesome. So, I have 4x squared is 2x minus 2x minus 1. What's the common factor here? Well, 2x. Okay. Pause it and think. What am I going to factor out here? What is the common factor? Okay, so you're back from pausing. -1 is the factor. Oops, wrong tool there. 2x plus 1. And, you might be noticing a pattern. Whenever we do the AC method correctly, we apply it right, we get a repeated factor here. 2x plus 1 and 2x plus 1 shows up twice. So now I can put the 2x and the -1 together. And you'll notice that, oh, these look very similar. They're basically the same thing, but one has a plus, one has a minus. Whenever you have what's called a difference of squares, there's no linear term, and there's subtraction, that will always happen. It can get a bit messy if your numbers aren't nice, but you'll always get this kind of factorization. So what can I do to make this faster? Well, I can notice that this is 4x squared minus 1 squared. So I have 4x, 1, 4x, 1. Because of this arrangement, parentheses squared minus parentheses squared, I can automatically translate to that arrangement. 4x and 1, 4x and 1. Put a plus here or a minus. Put a plus here. Just the opposite. The order, as before, the order that you put them doesn't matter. So I can have minus plus, or if I want, I can do plus minus, same thing. So that is a difference of squares. In other words, there's a formula for this. A squared minus b squared equals a minus b times a plus b. I'll often say that I don't want to have a bunch of formulas I have to memorize. I prefer to just understand broader concepts and apply them, know how to apply them. Memorizing stuff has its usefulness and its place, but especially in math, I try to avoid relying on memorization if I can. But this is so useful, and this shows up all the time in later math courses and science courses. So you probably should just memorize this if you haven't already. Maybe you have. Maybe from the very beginning, why doesn't he just do the a squared b squared thing? Maybe you did. Okay. So is this the last one? It is the last one. Okay. So this one's a little tricky. This one, hey, that's square 64. That's 8 squared. 9. That's 3 squared. But it's a sum of squares. So this one does not factor in a nice, convenient way. As we'll see later in the course, when we use imaginary numbers and complex numbers, that you can factor this, but that's a later topic. So although this is 8x squared plus 3 squared, this plus is a problem. This does not factor. Sometimes it's called irreducible, the technical term, and we can't factor that, at least not yet. Later in the course, when we cover complex numbers, we will have methods for that, but for now, we just can't. So that's basically it. That's module 0.2, and the next video will be for module 0.3.